Hey, good morning, gentlemen and Kylie.
Morning, Mr. G.
Good to have all of you here. Here we have a graph. This graph here was, I believe, of position, whereas number 9 is a graph of velocity versus time. So this requires another level of analysis. And what I like to do for these things right here to figure out what happens is to bring back our friend. And what is our friend?
A number line.
A number line. So let's go ahead and put a number line here like this right below. And on the number line, what do we place on the number line?
The critical numbers.
The critical numbers. Thank you, Kylie. Very good. Kylie, you've been paying attention in class. Very good.
Good job, Kylie.
You're making me feel good today. Thank you for making me feel good. Okay, so let's go put these, what are the critical numbers?
2.
1 and 5.
Okay, I'm saying 1
Aha, I knew it.
and 5
Sorry.
Yes, I was right.
and 6, or excuse, 5 and 7, right? 5 and 7. So here's 5, and here is 7. Now why do we say that these 3 numbers are critical numbers?
Because they equal 0.
They're 0, Mr. G. You tricked me,
Because
that's what it was.
because it's v of t is equal to 0. Okay, v of t is equal to 0, so that's why the critical numbers. Now, this brings in something else, and Aaron mentioned it, I think incorrect. I think I know what he's trying to say. What numbers were you talking about,
I
Aaron?
was talking about 2 and 3 and 6.
2 and 3. Let me go. And 6. Okay, this is going to bring another level of analysis, and I don't think, Aaron, I would have drawn that had you not mentioned it. But those are critical numbers also of a different level of analysis. So I hope you can see that in calculus this year that you've looked at a function, and when you go to calculus, you look at different levels of the functions. They have different dimensions, if that's the right word for it. So let's go, we say, what do we put on this number? By the way, we're going to put x of t down here. And what do we do on this number line the way we've analyzed things? What goes on top of the line here?
Oh, the pluses and minuses.
Pluses and minuses. So let's go ahead and put the pluses and minuses in place. What's going to go here between 0 and 1?
Plus.
A plus. Thank you, Gal. And then between 1 and 5? Minus. And then we go plus right here. So what this means is that if you have a plus here, it means that over this interval, x of t is going up. And between 1 and 5, x of t is going down. And between 5 and 7, x of t is increasing. Now, I want you just to look at that little sketch for a moment, like that analysis. How intuitive is that to you?
Very.
It is intuitive to you? Because it isn't especially to me, and I'll tell you why. I'll tell you why not. Because you have the velocity equation decreasing, but at that same time, x of t is increasing.
Yeah, that's kind of goofy.
Okay, it's kind of goofy. And because this is not especially intuitive, that's the main reason that if you stick to the number lines and use them as your friends, you're going to be able to get through these inconsistencies and incongruities and illogical appearing things. because that's what they look like. It's just not very intuitive. And so you have to use your tools of analysis. And to me, this is a great tool. And I'm going to introduce also another tool here today as well. And let's start answering the questions here. So the particle, here we have the velocity. When does a particle move forward, move backward, speed up? And again, we're talking about this whole, you can imagine this whole walking thing, right? We talked about back and forward, right? Positive, velocity is positive, velocity is zero, velocity is negative. You see, right? So, let's talk about A. When does a particle move forward? Okay, forward. Where's the particle move? When does the particle move forward?
Well, that would be between 0 and 1, and then 5.
Between 0 and 1. Okay, now here's the thing about it. Okay, 0, 1, and anywhere else?
5 and 7.
5 and 7. Because what's happened is just looking at the line, at the signs themselves tells you that, but below that is where you see the visual graphical representation of what the plus sign is. And so you can connect the plus signs with this function going up, negative sign with function going down, and then backwards. Let's see, particle move backwards and backwards. Where's the thing move backwards? In this little interval between, right? Between 1 and 5. You see that? Okay, next we're being asked, when is the particle's acceleration? Oh, we didn't have speed up and slow down yet, did we? Okay, this is where we bring in this second number line down here. And what this is this is going to be a of t, or the acceleration, which is the same as equals v prime of t, or equals x double prime of t. So we're looking at yet another level. And so here we have this other critical number here that Aaron mentioned. And so what is v of t doing? Decreasing. So that means your acceleration is going to be negative over this interval. So all the way from the starting place of 0 to 2. And what happens between 2 and 3?
0.
Yeah, it's going to be 0, not positive or negative, not increasing or decreasing. So that's, you don't see that very often. I'll just put 0 right here. And then we are increasing from 3 all the way to 6 and decreasing from 6 to 7. All right? So now we're going to use that to ask the questions about speeding up and slowing down. When is the particle speeding up? What do you have to have for a particle to speed up?
Positive.
From 3 to 6?
From 3 to 6?
Well,
No. Okay, this brings back,
because the velocity and stuff has to have the same sign.
yes.
Speeding up.
Oh,
So speeding up where?
Oh, it'd be something like 1 to 2.
Okay, yeah, so I don't want you to say this, there's another interval too. I don't want you to say it, Aaron. I want to see if I can draw other people.
Oh,
Okay.
fine.
So 1 to 2, right? That's one interval where the particle is speeding up. And
Okay, Leah Schick and Tori
So-
Sims to the office.
so why do you say the particle's speeding up there, Aaron? Or we'll have you say that. What do you see between 1 and 2?
They're both negative.
Okay, you see
They're lined
negatives down here, all the way from 0 to 2,
And a negative.
but that overlaps this negative only in this piece where velocity is between 1 and 2, right?
Mhm.
And so that's the overlap between the two. Signs are the same, okay? Now, someone else, is there any other place that you see the particle speeding up?
Going down.
Where do you see the particle speeding up besides what Aaron mentioned? Okay, if you go back to, well, I forget what the earlier note card we had down there. It talked about speeding up and slowing down. And what are the requirements of that? Kylie, you know that?
Just says speed increases when they have like signs.
Okay, speed increases where they are like signs. So speeding up where we have like signs. So where else do we have like signs?
5 and 6.
Between 5 and 6.
Yeah.
Okay? Got that? Very good. I know we drank it. Is that what you saw too, Aaron?
That is what I saw.
Yeah, I think Aaron crossed that safely.
Okay, good. And then slowing down,
That'd be where they're not the same. Or creative.
and so where do we see the slowing down occurring?
6 and 7?
Yeah, between 6 and 7, right? Because we're positive here, but that's overlapping a negative here. So I'm going to put 6, 7 right here. Anywhere else?
Yeah.
3 to 5?
3 to 5. Yeah, looks like that, right? That's a minus up here, but positive over that interval. So 3 to 5. Anywhere else? There is somewhere else.
Oh, I know it.
0 to 1.
0 to 1. Now, I think that's pretty well anywhere. Then you look to be sure that you don't have overlapping between these two, right? That would be sort of a check. And of course in this, and you don't want to have 2 to 3 here because that's just going to be a disqualified interval just based on the conditions there. Anyway, so that's it. Now typically what you do convention-wise is you probably list the left interval first in order, but is that 100% necessary? No, not really. Yeah, that's fine. That was fine. It's still good though. Okay, when is the particle's acceleration positive, negative, or 0?
Oh, we just found that out.
So B.
Positive sign.
Oh man, I glitched my pen out here. I have trouble with this pen here. There we go. Okay, here we go, B. So where do we have acceleration positive?
36.
So 3 to 6, yes. And negative,
0 to 2 and 6 to 7.
0 to 6 to 7. Six comma 7, that's 6,7. And AF AFT equals 0 on
2.
2 to 3. Okay, now, when does the particle move at its greatest speed? Greatest speed? On what interval or intervals?
Oh,
What did we say speed was? Hannah's not here to tell us what speed is. What is speed?
absolute value velocity.
Absolute value of velocity, right? So we have Kylie channeling Hannah. So if speed is the absolute value of velocity, when does that particle move at its greatest speed?
Oh, it'd be, at 0.
At 0, possibly, right? And anywhere else?
Oh, absolute value, so maybe like negative or like 2 and 3.
Yeah, maybe at 0, and we don't have the scale exactly, so we don't say on. Well, actually, it would be on, because that is an interval here. At t equals 0, and also on interval from 2 to 3. I mean, it just looks like that could be right, all right? When does a particle stand still for more than an instant?
Would that be like, way,
Three?
is that like 7 through 9?
Let's check her.
2 to 3. Now 7 through 9, really we don't see anything here, but I'm thinking 2 to 3 because the velocity is, wait a second,
The velocity is still negative, so it's.
the velocity is negative.
I think there's like supposed to be like, it's dark on 7 through 9.
Oh, okay, so you think it's supposed to be there, yeah, because that would make sense actually.
That's what it looks like on our paper.
Yeah, okay. On 7 through 9, so that's going to be, yeah, that would make sense, because if it weren't for 7 to 9, there would be no interval, right? So the only way that question could be answered is if 7 to 9 is there. So anyway, this is analysis, and I want to introduce to you the analysis tools for this. And we're going to see this at the end of your packet, and you can go to the end of your packet. I want to show you something right here. There's a chart that can help you with comparison of position, velocity, and acceleration. It looks like this. F prime, F double prime. Okay, do you see that?
There's a little like squiggly thing with that too.
Yeah, so Kylie's look, yeah, so she's also, you looked at the integral. Was it the integral of F?
Yes.
Integral of F, but we're not going to worry about that right now. We'll worry about this. And I'm going to make sure I get this right here. Yeah, that's what I thought. Okay. Okay, we have plus, minus, increasing, decreasing, concave up, and concave down. And below it, on the F prime level, we put plus, minus, and increasing, decreasing. And on the F double prime level, we'll put plus and minus. So this is a guide to tell you what's happening everywhere else. And then the top line that Kylie mentioned has to do with the antiderivative of F.
Oh, the antiderivative.
Antiderivative. We're going to talk about antiderivatives.
Something about that phrase, you know.
We're going to go there. So, but what it is, you can look both ways. And so I hope you can see in our sketch here that between 0 and 1, F prime is positive, because this is F prime here. This would be representative F prime. is positive, meaning that the function itself, that F itself, will be increasing. You see that? And so this chart can be really hastily put together every time to figure out what's going on. So that'll be very helpful, and I hope you can see retrospectively how this applies to setting up that stack of two number lines and looking at them together. And really, I wanted to go on to the next note card here today, but I think we've sort of come to a good stopping point over what we need to cover today. So we'll just resume on note card 24 on Monday. Any questions on this today?
No, I'm good.
Okay, we'll call it